So, a very good afternoon, students. Uh, Today I am going to start Unit 5th over here. Before starting Unit 5th, I would briefly revise the all Unit 4th, which I have covered. If you all people are having any problem in solving numerical problem in any topic, whether it's be a stability of slopes, bearing capacity, vertical stresses, and settlement of slope and deep foundation. In deep foundation I have not shared the numerical problem. I will be sharing numerical problem in deep foundation also. uh, Meanwhile, I am sharing some numerical problem which has previously came in gate examination on daily basis. Keep solving those numerical problem which I have been sending. Once the gate previous year question is being completed, I would be sharing some conventional question which have came in engineering services examination. So in unit 5th we all people are not having any numerical problem. It is basically theoretical part. It is like in this topic I would be covering something which is very usually used in fields, and I would take regular lectures on these topics in this week. Some topic which I have been teaching in geology also, like geophysical exploration, I would be sharing those videos also with you all people. Once if the time permits, I would try to revise these topics during Diwali vacation also, and I would keep sharing numerical problem related to previous year gate examination. So keep solving those numerical problem. Try to revise your concepts of unit 1, 2, 3 and 4 from any book like B.C. Punamiya, C. Venkatramaiah, V.N.S. Murthy, Brajam Das. So try to keep solving numerical problem with these books also, and try to revise your concept also. So we would like to try to understand what basically subsoil exploration is. So the process of collection of soil data for the assessment soil properties at a site through series of laboratory and field investigation is collectively called subsoil exploration. Enables the engineer to draw soil profile indicating the sequence of soil strata and properties of the soil involved. Main objective behind the subsoil exploration is determination of nature of the soil deposits, depth and thickness of the soil strata, horizontal extent of the soil deposit, and depth of the groundwater table and its fluctuation, engineering properties of soil, in situ soil properties, collection of soil and rock sample. So basically what attempts at understanding the subsurface conditions such as soil and rock profile, geological features of the region, position and variation of the groundwater table, physical properties of the soil and rock, contamination like groundwater contamination, general data of adjacent structures, hydrological data, topography, soil maps, seismicity, etc. Engineering properties of soil. All these parameters like soil and rock profile and geological features of the region, position and variation of the groundwater table, physical properties of soil and rock, contamination if any, general data of the adjacent structure, hydrological data, topography, soil maps, seismicity, etc. Engineering properties of soil is being determined with the help of subsoil exploration. Why we carry out subsoil exploration? To determine the type of the foundation required for the proposed project at the site, that is shallow foundation or a deep foundation. To make recommendation regarding the safe bearing capacity of pile load capacity. Ultimately, it is the subsoil that provides the ultimate support for the structures. So in this figure you can see the failure over here which has occurred. Leaning in a left side we are seeing the sinkholes, and on a right hand side we can see the leaning tower of the Pisa. So these are some geotechnical failure which you all people are seeing these images. So how we carry out the subsoil exploration? The three important aspects are planning, execution and report writing. Planning, to minimize the cost of exploration and yet give reliable data. Decide on quantity and quality depending on type, size and importance of the project, whether investigation is preliminary or detailed. Execution, collection of disturbed or undisturbed sample of the subsurface strata from the field, conducting in situ tests for subsurface material and obtaining properties directly or indirectly. A study of the groundwater condition and collection of sample for chemical analysis, geophysical exploration if necessary, laboratory testing on samples. Now after conducting all these things, you have to be very proactive in writing report writing. In report writing, description of the site condition, topographic features, hydraulic condition, existing structures, etc., supplemented by plans, drawing, description of the nature, type and importance of the proposed construction, description of the field and lab tests carried out, analysis and discussion of the data collected, preparation of the charts, tables, graphs, etc., calculation performed and recommendations. A complete site investigation will consist of preliminary work, collecting general information and already existing data such as study of the geologic, seismic maps, etc., at or near site, study site history, if previously used as a query, agriculture, land, industrial unit, etc., site reconnaissance, actual site inspection, to judge general suitability, decide exploration techniques. Exploration, preliminary investigation, exploratory borings or shallow test pits, representative sampling, geophysical investigation, etc., detailed investigation, deep boreholes, extensive sampling, in situ testing, lab testing, etc., depth and spacing. In general, depth of investigation should be such that any / all strata that are likely to experience settlement or failure due to loading. Spacing depend upon the degree of variation or of surface topography and subsurface strata in horizontal direction. Refer to Alam Singh and Gopal Ranjan Rao. So this is the way you all people have to draw the bore log. So in this figure you can very clearly see that up to this level there is a sand which is compact coarse to medium sand cell fragments. Up to this depth there is a clay, molten brown and grey cleanish clay. Up to this strata there is a sand strata. So in this way you have to prepare a bore log data once you carry the all the test has been created, well completion details, your every details is being given in this bore hole log data. So this is a another view. This is actually this is the topography of a subsoil given with the help of bore log number 1, bore log number 2, bore log number 3 and 4. So with the help of 4 bore logs, topography beneath the earth surface is being drawn. Methods of subsoil exploration. Exploration methods: number 1, direct methods, in which we go for test pits, trial pits and trenches. And number 2, semi-direct methods like boring. In boring we have agar boring, agar and shelf boring, wash boring, percussion drilling and rotatory boring. Indirect methods are sounding or penetration test and geophysical methods. So in test pits, depth up to the 3 meter, uneconomical at the greater depth. Supports are required at the greater depth, especially in the case of a weaker strata. Problems with groundwater table and same should be lowered. Open type exploration. Soils are investigated in a natural condition. Soil samples are collected for determining strength and engineering properties. Walls of the test pit indicates 4 layer. Number 1 clay silt, number 2 sandy silt and number 3 clean sand, number 4 sandy gravels. So in a way you can give the stratigraphy and finds in layer 1, L1, L2, sandy soil, type of soil, their colors, their findings and their chronology. So this is the way you get details about the subsoil with the help of trenching pits. So this is a excavated test pit. This is very necessary to go through these test pits if you are going for any type of construction, any type of infrastructural development like building, hospitals, hotels, bridges, flyovers, tunnels, any kind of construction you are going to. You must know about the subsoil condition of that soil. What is what type at what level. Which type of soil is present over there, then you will going to decide the foundation over there, at which level water table is available. Boring. Drilling a hole into the soil strata up to the specified depth is known as boring. Number 1, agar boring. Number 2, agar and shell boring. Number 3, wash boring. Number 4, percussion drilling. And number 5, rotary drilling. Agar boring. Drilling is made using a device called soil agar, power driven up to 3 to 5 meter and hand operated greater than 5 meter. Advancement is made by drilling the agar by simultaneously rotating and pressing it into the soil. Dry and unsupported bore holes. When the agar gets filled with same soil same, it is taken out and the soil sample collected. This is in a figure you can see soil agars. It is actually it is a image from a book. It's a post hole agar and this is helical agar, and this is a field example of soil agars. Agar and cell boring. Casing is provided in case of weak strata, and first the casing is driven and then the agar. Boring rig is used for power driving, hand rig depth for up to 25 meter. Soft rocks are broken using chisel bits, and sand bumps are used in case of a sandy soils. Disadvantage: whenever the casing is to be executed, the agar has to be withdrawn with the which hinders the quicker progress of the work. Wash boring. Below groundwater table may not be used for the soil mixed with the gravel and boulders. Initially, the hole is advanced for a short depth by using a agar. Then a casing pipe is pushed in and driven with a drop weight. The driving may be with the aid of the power. A hollow drill bit is screwed to a hollow drill rod connected to a rope passing over a pulley and supported by a tripod. Water jet under pressure is forced through the rod and the bit into the hole. This loosens the soil at the lower end and forces the soil water suspension upward along the annular surface between the rod and the side of the hole. This suspension is collected in a settling tank. Soil particles are allowed to settle down and water is allowed to overflow into the sump, which is then recirculated. Very disturbed sample is obtained, hence cannot be used for determining the engineering properties. Whenever a soil sample is required, the chopping bit is to be replaced by a sampler. The change of the rate of the progress and change of the color of the wash water indicate the change in the soil strata. So this is a typical set for wash boring. You can see over here, here is a chopping bit replaced by sampling spoon during the sampling operation. Water flow, hollow drill rod, casing, settling tank, suction pipe, pump, water hose and tripod and pulley. So this arrangement can be seen by you all people. So this is the field example of wash boring. It is same like standard penetration test arrangement. Percussion drilling. A heavy drill bit called churn bit is suspended from a drill rod or a cable and is driven by repeated blows. Water is added to facilitate the breaking of a step soil or a rock. The slurry of the pulverized material is bailed out at the interval. Cannot be used in a loose sand and is slow in plastic clay. The formation gets badly disturbed by impact. Rotary drilling, suitable for the rock formation. A drill bit fixed to the lower end of the drill rod is rotated by power while being kept in a firm contact with the hole. Drilling fluid or bentonite slurry is used under the pressure, which brings up the cutting to the surface. Even the rock score may be obtained by using suitable diamond drill bits. Disadvantages: not used in porous deposit as the consumption of the drilling fluid will be high. So this is a way you can see in a figure. It is a and field example of rotary drilling. So it is the drilling bit over here, drilling fluid pressure over here, junction box, drilling rod, rotary head, down thrust, and pass hole recording and printing the hole back and all those things. Indirect method is sounding on penetration test and geophysical methods. So SPT is being given in IS 213/1986. This is a standard penetration test. Once again, I am discussing it. In Unit 2 also I have discussed about this. Generally used for cohesionless soil to determine the relative density, angle of shearing, resistance and unconfined compressive strength. A borehole is made using a drilling tools and a hammer of weight 63.5 falling from a height of 750 mm at a rate of 30 blows per minute. After reaching the specified depth, the drilling tool is replaced by a split spoon sampler to collect the soil sample. First 150 mm penetration is taken as a seating drive and number of blows required for that penetration is discarded. Number of blows required for next 300 mm penetration after seating drive is taken as standard penetration number n. Number of blows greater than 50 are taken as refusal as the test is discontinued, and correction are applied to the observed n value. So this is a way arrangement is being done. This is borehole over here, ground surface, drill rod, anvil, slip or guide pipe, 30-inch fall. This is donut hammer, rotating cat head, and crown sieves or pulley, typically 1 inch in diameter. So this is the arrangement you can see in some videos also, and in books also you can find these arrangements for standard penetration test. What is correction to the n value? Two types of correction we have in our course, that is dilatancy correction and overburden correction. Of these, overburden correction is applied first, and to that corrected value dilatancy correction is applied. Dilatancy correction, due to the presence of fine sand and silt below the water table, negative pore water pressure develops with increase the observed n value, hence correction is applied, and dash is greater than 15 or n is equal to 15 and dash is equal to n is equal to 15 plus half and dash minus 15. Overburden correction, soil having the same relative density will show higher n value at the greater depth due to the presence of overburden. Cohesionless soil are greatly affected by confining pressure, hence n value is corrected to sigma is less than equal to 280 kilonewton per meter square, n is equal to n dash into 350 upon sigma plus 70. So these are some SPT correlation for cohesionless soil. Serial number is given in column 1, and condition very loose, medium sand, dense, very dense. These all things are given. N values, for n values between 0 to 4, relative density lies between 0 to 15%. Phi is less than 28 degree. For n values 4 to 10 degree, relative density lies between 15 to 35%, and angle of shearing resistance lies between 28 degree to 30 degree. And for n value which is lying between 10 to 30, our relative density is between 35 to 65, and our angle of shearing resistance lies between 30 degree to 36 degree. For n value 30 to 50, relative density is 65 to 85, and phi is between all those. So you can go through this chart. This is n value SPT correlation for clays, very soft, medium, stiff, very stiff and hard. So for depending upon the number of n value, you can determine the chart has been derived for unconfined compressive strength in kilonewton per meter square. Like for 4 to 8 you have got 50 to 100 kilonewton per meter square for any clay. Similar test is the static cone penetration test, which is also known as SCPT. This method is used to determine penetration resistance of soil, also known as dust cone test. Cone dimension are apex angle 60 degree, overall diameter 35.7 mm, and area 10 cm square, rate of penetration 10 mm per second, depth of penetration 35 mm per second. So this method is used to skin friction values, which is used to determine the length of the piles. The cone is pushed only by thrust and not by driving. In order to find out the cone resistance, the cone alone is pushed. Later the cone and sleeve is pushed together to find out the combined frictional and point resistance of the cone. Hydraulic gauges are used for measuring the pressure developed. Frictional resistance equal to combined resistance minus cone resistance. Modified cone penetrometer is known as refined dust cone. Cone penetration resistance is denoted at QC in kilonewton per meter square. Unlike SPT, this method is also suitable for clay deposits, unsuitable for gravels and dense sand. For such, soil dynamic penetration is used. So this is some point cone resistance versus SPT correlation. Types of soil: gravel. So for there is a comparison between the values of SPT and point cone resistance value. You can say see it for gravel, sand, silty sands and silts and clay sand silts. So cone and friction assembly, this is an assembly, this is a 60-degree apex angle, 3.35.7 times 5 cone assembly is like its height is 100 mm. So these things you can see anywhere, you can find this is friction jacket over, and the dimension is given in mm. Cone without threads, cone adapter, threaded cone is given, and their dimension is given over here in this figure. You can see clearly, and you should try to remember all these details. Typical set for SCPT, this arrangement is same as SPT only. This is driving head, this is guide rod of and height of all 750 mm, this is weight of hammer 65 kg, this is driving rods and arrangement keeping the rod vertical. These arrangement, this is tripod stand, this is pulley over here. So arrangement is just like SPT and was flooring only. Geophysical method, the stratification of the soil and rock can be determined by geophysical methods of exploration, which measures changes in certain physical characteristics of these material, for example density, magnetism, electrical resistivity and etc. You all people have gone through these methods in geology also, and I would be preparing some separate lecture on geophysical methods for geology students also, so I would be sharing those methods with you all people. And I am talking about these geophysical methods in brief over here. Seismic refraction method and electrical resistivity method. Seismic refraction method. The seismic refraction method is based on the principle that seismic waves have different velocities in different types of soil. The seismic refraction method is more suited to shallow exploration for a civil engineering purpose. So this is a way energy resource is being given, and here detectors are being applied. So V1, V2 bedrock, so this velocity is being tabulated with the help of these detectors over here. And after all, this time versus distance graph is plotted with the help of velocity which is being determined, and the slope of this graph, once we know the distance from the energy source of the detectors is known to us, and the time required to reach the wave from this portion to this portion is recorded over here, and with the help of those things we plot this curve, and with the slope of these curves gives the velocity over here. So the electrical resistivity is given by rho is equal to 2 into 3.14 into D into V upon I, where rho is equal to mean resistivity ohm per meter, D is equal to distance between electrode, V is equal to potential drop between two inner electrodes and volts, I is equal to current applied to outer electrodes and ampere limitations. The methods are capable of only strata having different electrical resistivity. The services of an expert fields are needed. So students, I have discussed many things, and the portion which is being left over here is being discussed by me in subsequent lectures. Geophysical methods will be taken for geology students separately, so I will be sharing those videos with you all people also. Thank you once again for your patience listening. Try to revise all these things and keep yourself involved in solving numerical problems which have been shared with you all people, whether it's be from GATE previous year question paper or engineering services previous year question paper. Try to solve those things on a regular basis, otherwise you all people will be lagging somewhere with the concept of geotechnical engineering. Thank you students, thank you for listening to me.